Welcome to the Trailblazer event. I'm going to be talking today about scaling Blazor web applications. I'm Shaun Walker. I'm the founder of DevEssence. We are the original, creators of the Trailblazer conference. I'm in Microsoft MVP. I've been lucky enough to be a Microsoft MVP for, 17 years now. I had two different sort of stints as an MVP. I was an MVP early in my career, and then I actually kind of lost the designation for 5 years, and then I was able to get the designation back again. But overall, 17 years of being an MVP, and I find that to be quite a valuable designation because it has allowed me to have more direct access to Microsoft, to participate in a lot of the MVP community events. It's definitely a valuable program for those who are interested. But of course, it takes a huge amount of effort in terms of the volunteer commitment to the .NET community, right? In terms of providing content and volunteer effort. I'm the creator of Oqtane, which is an open source project that some folks consider to be a CMS, some folks consider to be a web application framework. I'm also the creator of DotNetNuke, which was also a CMS / web application framework that was popular quite a number of years ago. I originally created DotNetNuke back in 2003, so it has been around for a long time. I'm actually not involved with DotNetNuke anymore, and I spend most of my efforts on open source efforts on Oqtane. I've also been a volunteer member of the .NET Foundation for a long time. More recently, I guess since 2020, I've been participating in the project committee as a volunteer. I led the project committee as its chair for, 5 years until last year, and helped with a lot of .NET Foundation items over time in terms of shepherding open source projects into the foundation. All right, so let's talk about scalability for a moment. So software scalability, what is the definition of it? So scalability is a system's ability to handle increasing workloads, such as more users, more transactions, or data without compromising performance or requiring a complete architectural redesign. So that definition does a pretty good job of describing scalability. And you can't talk about scalability without sort of considering the two most popular ways of scaling systems, and that would be referred to as vertical scaling and horizontal scaling. Vertical scaling is basically adding more resources to a single kind of machine in your infrastructure, or it might not necessarily be a single machine, but sort of adding more resources to a workload in your environment. So if you have a server that's handling sort of the compute aspects of maybe the web aspect, you can add more memory or more CPU. That would be vertical scaling. Similarly, if you have a database server and maybe you add more memory or a higher powered CPU to it, that would also be vertical scaling. The other approach to scalability is horizontal scaling, and that's where you add more instances of hardware to your infrastructure to run more workloads. So this is sometimes called scale out. So horizontal is scale out, vertical scaling is scale up. And so these are the two most popular ways of improving sort of the scalability from an infrastructure perspective. If we look at application architectures, this is kind of another way to look at scalability. There's a variety of different ways that you can develop software applications today. On the left-hand side, we have monoliths, which are an application that is probably in its most simplest form and runs on the least amount of infrastructure. Next to that, we have client server, where we have sort of the two different front end and back end workloads split. And so those can be run together, but often they would be split onto different infrastructure resources. And in that way that you can achieve greater scalability. Microservices have been popular for probably at least 10 years, maybe 15 years at this point. And in this way, you would build your back-end services as distinct workloads, and those workloads can be deployed on different infrastructure, meaning that you can scale them out sort of horizontally on the back end and have dedicated sort of resources for each service. Typically in a microservice architecture, you would still have sort of one monolithic front end, or at least that's the way it was traditionally done. And then on the far right-hand side, you have micro front ends, and this is where you would actually be splitting the front ends into different applications that can be deployed separately, and they can be developed separately, and they might be deployed into the same infrastructure or actually onto different infrastructure. So you have like a sort of very broad array of different architecture choices that you can make when you're looking at scalability options. I think the most important thing is to kind of look at the requirements of your application, like what is the expected number of users that are going to be using it? What are the behaviors of those users? Are they going to be mostly just consuming content? Are they going to be contributing content? Also looking at the where those users come from, like what geographical area are they from, what time of day do they usually hit the system? Is it all at one time in sort of one big spike? Like there's sort of, you have to profile basically what your audience is going to be for your web application, and then you can start to make the right decisions around the architectural approach. My general I guess recommendation when it comes to deciding on an application architecture is to kind of choose the simplest architecture for the target audience, right? Because the simpler the architectural approach, the faster it's going to be to develop the system, the easier it's going to be to deploy the system, and the easier and probably less costly it's going to be to operate the system at runtime. And so I think that like there was some dogma kind of in the community for a long time of, by default, choose microservices, right? And so that's choosing a very complex architecture approach. And a lot of folks chose that approach when they actually didn't need that much complexity, right? They probably, for like 90% of cases, you can probably get away with something that's much simpler. Even a monolith or a modular monolith will satisfy your needs, and you don't need the extra complexity of a microservice-based architecture. Obviously, if you have a very large audience, right, and a large number of users, or you're building a system that's intended to scale to a massive amount, then you absolutely should choose microservice-based approach. But I mean, to go down that path sort of prematurely and optimize prematurely, you're basically going to, spend a lot more money on the development. There's going to be a lot more complexity, and when you try to run the system, it's going to cost a lot more money to operate. And so these are kind of the higher level decisions you need to make about scalability. So when I was thinking about this presentation and how to create a scalable Blazor application, I thought, well, what are people going to do today, right? And I guess in this age of AI, we've become quite accustomed to just ask an LLM, what does it say, what does it recommend? And so I asked an LLM, how do I create a scalable Blazor web application? And the initial answer, sort of the summary version of the response, was creating a scalable Blazor application is less about Blazor itself and more about designing the architecture so that the UI, APIs, data layer, and infrastructure can grow independently. This is a great answer. I mean, this is a perfect answer. However, it doesn't really give you much details on how you would go about creating that application, but absolutely what AI came back with as a response is completely relevant. So then, of course, you want to dig a little bit deeper and give me some examples, like on sort of recommendations on things that I should do in creating a scalable Blazor application. And it came back with a fairly decent list of items, right? Like choose the right Blazor hosting model. That is the number one thing that it came up with. Separate UI from business logic, build APIs as independent services, use stateless approaches, use dependency injection, minimize data transfer. Use virtualization, which I'll explain in a bit. Use caching, make database access efficient, use background processing where applicable, add observability, and prepare for horizontal scaling. So I think that absolutely all of these recommendations that it made are like completely applicable to building a scalable Blazor application. And so it's then, digging deeper into each of these. So when we start with number one and then choose the right hosting model. So it's kind of interesting what the LLM came back with as a recommendation. Basically said for high scalability, use Blazor WebAssembly. That was the recommendation. It didn't really talk about any of the other hosting models. It just said that if you want to achieve high scalability, you should use Blazor WebAssembly. And then it explained that the benefits of using that approach were that the UI is designed to run in the browser. Um, the server resources then are reserved primarily for back-end processing for APIs and things of that nature. And the scaling becomes similar to what it would be when you're scaling a React or an Angular sort of JavaScript framework-based application. So those benefits are all, I guess, true. But I would say that using Blazor WebAssembly isn't always the optimal solution for creating a scalable Blazor application. And so I'm going to disagree with what the LLM came back with here, and I'm going to explain why. So first of all, let's talk a little bit about Blazor hosting models. So we have, I guess, 3 different Blazor hosting models that Microsoft has provided as part of the feature set for Blazor. Obviously, these hosting models have evolved over time, so not all of them were available when Blazor first became available. Blazor Server was the first hosting model that Microsoft provided. Blazor Server runs on the server, and it uses a SignalR connection to interact with the web browser. And so all of the processing actually happens on the server, and it maintains a persistent connection using a WebSocket, using SignalR to interact with the web, like with the browser. And so that's one of the hosting models. Second hosting model is Blazor WebAssembly. And so with Blazor WebAssembly, you would build the application, you would compile it into assemblies, and then at runtime, Blazor will actually transfer the applicable assemblies to the web browser where they will run natively. And so, where the LLM was recommending that for scalability purposes, Blazor WebAssembly is the recommended choice. When things are, of course, running natively in the browser, that does provide a great deal of scalability, and JavaScript-based frameworks have proven that over time. Blazor Hybrid is really an option that you would use if you want to target, other types of devices. It's more intended for, mobile or desktop, and it allows you to build a Blazor application that is deployed to a device, and then those components actually run natively on the device. But again, the components have to be deployed to those devices before they're able to run there. And so we're more focusing in this presentation on web and not so much on, mobile or desktop kind of devices. So for the rest of the presentation, I'm going to focus more on Blazor Server and Blazor WebAssembly. And so some of the challenges around, Blazor hosting models, at least for Blazor WebAssembly, let's talk about that first, is that initial request that a browser makes needs to download assemblies to the browser. And then, of course, it needs to load those assemblies before it can sort of instantiate them and run them natively in the browser. And depending on, the size of those assemblies, there's going to be some latency, right? There's going to be a delay in the time it takes for a new user using, a new browser instance to be able to get your Blazor WebAssembly application up and running. The amount of latency might be unacceptable for your audience, right? And so because of that, maybe Blazor WebAssembly might not be the best choice in some cases when you're building a Blazor web application. Blazor Server, on the other hand, does have some resource constraints because the Blazor application is running on the server, and because each user that connects through a browser has a certain amount of state that is maintained within the SignalR connection, there is resources that are being consumed on the server, right, for each user. And so, as your number of users increases, it's going to increase the amount of resources that are required on the server. When resources, I'm talking primarily about memory, right? Each user will have a certain amount of memory that is, maintaining the state for that SignalR connection. And so because of that, there are some resource constraints that you have to be aware of when you're using Blazor Server. However, if depending on the size of your audience, that you might not ever run into those resource limitations using Blazor Server. So these are the things that you need to be aware of in terms of the hosting models. And so you can't just sort of blindly take the recommendation from an LLM when it says use WebAssembly if you want to build a scalable Blazor application, because that's not exactly true. You need to do a bit more analysis than that to understand your audience. And even beyond the Blazor hosting models, in more recent versions of Blazor, Microsoft introduced the concept of render modes, right? And so the early versions of Blazor were all using what I guess we would refer to as interactive Blazor, right? The entire Blazor application was expected to be interactive. And that was true regardless of which hosting model you were using, right? If you were using Blazor Server, the entire Blazor application was, determined to be interactive in nature. And so that's why it would actually maintain, more state, more memory consumption would be required to run a Blazor application in interactive render mode using, Blazor Server. If you were using WebAssembly, right, that entire, WebAssembly application that's running in the browser is interactive. And so later, I guess, in order to satisfy some other requirements and actually to produce or allow developers to create applications that are more scalable, Microsoft introduced the notion of static Blazor, and this was in .NET 8, so which is more than 2 years ago now. .NET 8 was shipped, and that's when Microsoft introduced static Blazor. Static Blazor has a bunch of different names that people call it. Sometimes it's called static server-side rendering, or SSR for short. Some people refer to this model as Blazor Web Applications. And so because of the fact that there are multiple names for this, it sometimes creates, I think, confusion in the developer community in terms of like what actual render mode you're using when you're developing a Blazor application. But these render modes are important. Static server-side rendering, the idea behind it is a lot of applications have a lot of content that are static in nature, right? And an example here is, a browser. It has a navigation at the top. It has a footer at the bottom. It has some sidebar content. And all of that content is static, right? It doesn't change. There is no interactive aspect to it at all. And so because of that, if it doesn't make sense for this entire Blazor application to be interactive when a lot of the components don't have any interactivity requirements at all. And so the idea behind static Blazor and static server-side rendering are that the output of a particular page can be rendered on the server and then sent to the client, and only those components that require interactivity can sort of light up and become interactive. And using this approach basically conserves a lot of resources, right? So you're not basically requiring that the entire application is interactive. Only certain components are interactive, which reduces sort of a lot of the resource consumption of the application. one of the other things, though, that people are not aware of is that static Blazor, or it's sometimes called static server-side rendering, SSR, any of these names, some people think that it's basically just MVC, right? They think, or Razor Pages, right? They think it follows the same model that the legacy Microsoft technology stack followed. And if you're using static Blazor, that is basically just rendering content statically on the server in the same exact way that MVC would. And that is actually not true, because when Microsoft introduced static Blazor, they introduced the notion of something called enhanced navigation. It's maybe a bit of a strange name, but it basically allows a server-side Blazor application to behave like a single-page application, right? A SPA application. But it allows it to behave like a SPA application without interactivity. And so, of course, the way it does this is it's still using essentially a JavaScript library on this, on the browser to handle this. A page will be effectively, rendered on the server, and then the browser will do a difference between the output that's on the server and the output that's currently in the browser. It'll determine what the differences are, and then it'll patch the browser, the DOM, with any of the differences. And this is the exact same approach that JavaScript frameworks like React and Angular have been using for a long time. Essentially, it's the same approach that Blazor uses when it's in the interactive mode. However, it's accomplishing the same thing by running on the server. And so because of this enhanced navigation, you'll find that Blazor applications behave differently than MVC or Razor Page applications, meaning that the application still appears to be very responsive. There are not any full page refreshes when you're using enhanced navigation and static Blazor. So it'll provide a much better user experience for the end user. And then in those particular cases where there are interactive components, those will behave using the techniques that interactive Blazor uses, and that would be either using the Blazor server hosting model or the WebAssembly hosting model. But it's important to recognize that static Blazor kind of is its own unique render mode, and it has certain behaviors that are part of it. And so when you're looking at an application and building a new application, then you do, like I mentioned earlier, have to understand what your target audience is. If you're building an application that is primarily consumer focused, meaning it's public facing, it might have a lot of sort of static content in it. Maybe the majority of the users that are connecting to this web application are, not authenticated. Then static Blazor is absolutely the best choice for that, because there are so few interactivity requirements. That's exactly the scenario that static Blazor was designed for. Whereas if your application is primarily contributor focused, or primarily interactive in nature, meaning almost all of the users are going to log in, they're going to be authenticated, and they're going to interact with the application in some way by taking various actions, then you're better off creating a interactive Blazor application, and probably a fully interactive Blazor application. And so it's kind of interesting because I think when Microsoft first introduced Blazor, and they introduced it using, interactive Blazor, and with the two different, of course, there's the two different hosting models, Blazor Server and Blazor WebAssembly. I think people thought over time that Blazor Server would become a lot less popular, and that everyone would basically shift over to Blazor WebAssembly because, in theory, it behaves a lot more like a JavaScript framework, and all of that logic then runs on the client. So in theory, that's great. But because of the limitations of Blazor WebAssembly, which I mentioned earlier, and the fact that it has to download assemblies to the browser, it's not always the best choice. So, I mean, from real world experience, we're finding that a lot of folks are, especially if they're building like a website, for example, and the vast majority of users of that website are public users, anonymous users. They're not going to be authenticated. Um, Static Blazor is a great choice for that. That same website might have certain personas, like maybe an administrator persona, where there's a small number of users that are expected to log in and become authenticated, and then they can manage the content. Um, and in those particular cases, there might be aspects of the application that are interactive. And in that case, you don't necessarily even need to choose Blazor WebAssembly. Right? You can use Blazor Server. Blazor Server is a very capable interactivity model. And if you only have a small number of users that are going to be using Blazor Server, then the amount of resources that are going to be used on the server for those specific users is actually fairly limited. And so the scalability of that system is still going to be very, very adequate. Whereas we have some clients that are building, I guess, what I would almost consider to be a desktop application. Um, as a web application, right? And I call it a desktop application because it's basically like almost like an intranet scenario where all of the members of the company have an account. When they access the system, they're expected to log in, so they're authenticated, and they have a variety of different features of the application that they're expected to interact with. And so in those scenarios, it makes sense for you to use the fully interactive Blazor mode because the bulk of the users are interactive in nature. And then you have the option there that you could use Blazor WebAssembly or you could use Blazor Server. And we're finding even in that scenario, Blazor Server is quite capable, and you rarely run into scalability implications in your infrastructure. And so the fact that AI recommended Blazor WebAssembly is a little odd to me, but that's also, I guess, why you can't always believe what you get back from AI. And so maybe digging into that a little bit more, like why does AI recommend WebAssembly as like the preferred way to build a scalable Blazor application? Well, the reality is Gen AI, right, is not intelligent at all, right? It basically just generates content based on its training data. And so if it has a large amount of training data available that kind of pushes it in a certain direction, then that's what it's going to recommend. For technology like Blazor, there is a whole lot more content that's available about Blazor WebAssembly than there is about Static Blazor. Static Blazor only came out like 2 years ago, whereas Blazor WebAssembly was introduced like 6 or 7 years ago. And so the amount of training data that is actually being fed into AI systems dictates sort of what it's going to recommend. And also, I think I mentioned this already, the terminology also matters. So I think Gen AI gets a bit confused. It doesn't always relate static Blazor, Blazor server-side rendering, Blazor SSR, Blazor web apps. It doesn't always relate all those to kind of a single category of application. I think it kind of sometimes thinks that those are different things. And so as a result of that, LLMs can get confused as well. And so I guess the end result of all of this is that this is exactly the reason why you can't always just take the recommendation from AI at face value. You should always do a bit more research and dig into the subject and to truly understand like why things are being recommended, because it might not always be the right recommendation. And I guess on that note, a bit of a sidebar, maybe a little bit of a soapbox rant, but so based on the fact that Gen AI recommendations are based on the volume of historical content on a particular topic, it means that a lot of like legacy solutions have a lot more training data available. And so that they are always going to be recommended more than the newer, more innovative solutions. So it's interesting. Like this is great for incumbent solutions, I call them. So when you're building like web applications, there is so much information that's available about React or Angular at this point that there is no doubt that those JavaScript frameworks are going to be recommended like 90% of the time, right? Like it's only if you include a lot more specific criteria in your prompt that it's going to recommend anything else but those systems. And that's because the training data, right? The training data is much greater for those. Another example would be for CSS frameworks. There's tons of training data available on Bootstrap. So Bootstrap is always going to be recommended. That doesn't mean that a CSS system like Tailwind isn't like better in some ways, but again, Gen AI and LLMs are not smart, right? They're purely going to based their results based on probabilities, and that probability is based on training data. And so this is just something, of course, you always have to be aware of, that the answer that you're getting back is not always going to be the best solution, the most innovative solution. And I guess sort of like my fear is that the more that we rely on Gen AI sort of at face value, based on its recommendations, and don't bother doing any additional research, the more we as a society is just going to stop progressing and begin to stagnate, because there is no point in innovating any longer if if everyone just leans on that crutch of AI and basically takes the first recommendation. So sorry, I'm going to step off my soapbox now, but it is one of my fears for society in general. And this isn't a fear just for software development in general, but it's a fear across every category of information that people might be using AI to query on. It sort of naturally sort of stifles innovation, right? It doesn't allow new solutions to percolate to the top, just because of the very nature of the way that LLMs and Gen AI work. All right, so getting back to the real topic is Blazor Scalability. And so we've talked a bit up here about choosing the right Blazor hosting model. And I'm going to kind of walk through some of these different elements here for scalability. And I'm going to do that in the context of an application. So I'm going to do a demonstration, but the demonstration is going to be based on Oqtane. Oqtane is a Blazor solution that I started developing, when Blazor was still a experimental product at Microsoft. So I think that was back in 2018 that I first started creating Oqtane. It was originally designed as an application framework. Some people consider it to be a CMS because the sort of definition of a CMS is pretty broad. It supports, of course, Blazor, and one of the, I guess, benefits of Oqtane is it is not specific to a specific hosting model or render mode. It supports all of the hosting models and render modes that Blazor has released over time. And it can also be used with .NET MAUI through the Blazor hybrid approach. And I'll explain about that in a minute. But before we going there, so one of the things, so for those people who are, have some awareness of Oqtane, so in the past, when Oqtane was originally created, it took the same approach that I had taken with the previous, web framework that I had created called .NetNuke. And that approach doesn't necessarily, I guess, align with the development patterns that developers, especially those that started with .NET Core, are familiar with or comfortable with. And so because of that, I think it had more limited adoption. Because of that, there were certain things that were part of it that were a little bit harder to understand, maybe a little bit harder to develop, to debug, maybe a little bit more difficult to understand the deployment strategy around it. And so last year, I decided that I should try to make Oqtane follow the patterns that modern developers are more familiar with. And so I basically created a new distribution of Oqtane that is NuGet based, and essentially you consume it into an existing Blazor application the same way that you would consume any other NuGet package. We also created an application template that you can use using, the .NET CLI to create a new application. So basically, you can install that application template using .NET install. You can spin up a new application using .NET Oqtane app. And then at that point, you essentially have a Blazor application. But you have a Blazor application which already has sort of Oqtane wired up through NuGet package dependencies. And as a result of that, you get a lot of additional functionality. And I'll show you that in a moment. All right, and so with that, I'm going to switch over to Visual Studio for a moment here. And so in preparation for this talk at Trailblazer, I wanted to kind of create a semi, I guess, real world application that would be able to demonstrate some of these different aspects of scalability using, a Blazor application. I created this application using the Blazor application template, using that exact, CLI approach that I just described. And then once you have the application created, it is just a standard, Blazor application. However, it does follow a certain architectural approach where it has the client application as a separate application. And this client application is where all of your Razor components would reside. It has a server application where all of your APIs and other types of workloads would reside. And then it has a shared project for the models or any utility code that is going to be shared between the client and the server. This application, so my daughter, my daughter plays professional rugby now. She actually just was drafted by a professional rugby team in the United States. This is a league called the Women's Elite Rugby League. Rugby in general, I think, is not as popular of a sport as a lot of other sports, especially in North America. And so there's not a lot of great avenues for, rugby players, especially women's rugby players, to kind of showcase their skills and their capabilities. And so I thought, I'm going to create an application that is like a rugby resume for a female rugby player. And I thought, what is the best sort of application to emulate to do that? Well, LinkedIn is essentially, an application that people use to showcase their resume. That's in the context of companies that they've worked for and their career and their skills. But you could do the same kind of thing for a sports organization or a specific type of sport. And so I thought, okay, I'll use Oqtane and I'll build basically a LinkedIn clone that is more focused on sports. And I probably spent a couple of weeks building this. And I think that it would have taken much longer to build an application like this prior to AI. Like, obviously, everyone is utilizing AI now. There's a picture of my daughter, but so this will look familiar to you once I click into the profile. So I'm logged in as a specific user. We've got the page with the layout that looks a lot like LinkedIn. We've got all of the demographic information about this particular member. We've got an about. We've got their experience, right? The teams that they've played for. They can make posts. They can outline their achievements that they've accomplished over time, and they can follow other members that are part of the rugby community or teams that are part of the rugby community. I can click through on a team, and I can see that we have a team page. This is sort of akin to the LinkedIn company page, right, where there's a banner, there's a logo, there's information about the team, about information. There's the members that play for that particular team. Posts that team may have made. matches that they played against other teams, their achievements, right? So I think the fact that I was able to sort of create an application with this level of functionality using Oqtane in only a couple of weeks kind of just speaks to how AI has changed the game. And I guess in regards to that, I would say that, everyone uses AI differently. Um, the presentation that was done to kick off the Trailblazer conference by Sriram was focused more on like using agentic methodology, using skills. Um, I personally also find that the sort of AI assisted development is also very powerful because as a software developer, I sort of know the functionality that I intend to implement. And I find that sometimes rather than creating prompts to do that, I'll, I can start writing the code and AI will make suggestions of what it thinks the code should be, and often it's right and you can just tab through it and it just generates a whole lot of code. I find that style to be quite powerful because I'm then reviewing the code in the context of like thinking about the problem that I'm trying to solve, and that is still very productive, maybe not as productive as using the fully agentic approach and using skills. But I mean, there's so many different ways that you can use AI. All of it is productive. And I think that that's like sort of my general message about that. So this application, as you can see here, it has a lot of sort of LinkedIn functionality to it. If I want to go in and I want to edit anything, right, I have sort of an edit experience where I can go in and it provides sort of a modal experience. These modals are interactive components, whereas the general page, right, is static. So this is a static Blazor application, and it has certain components that are interactive. But I mean, those interactive components are only used when the user decides that they need that extra bit of interactivity, right? And so we've got a lot of different capabilities that are outlined here. So if I close that for a moment, and we're going to go back to sort of the general principles about creating scalable Blazor applications. So we already talked about choosing the right hosting model. And I already mentioned that in this case, we're using Blazor or static Blazor, and then we are using interactive components where necessary. So by default, if I go into the client area of this application, let's say we go into the member module, this index component here is a static component, right? It is the default rendering of a member with all of the information, and it doesn't need to be interactive. All of that is static information. It, of course, has various like links that are part of that page that can then launch additional components. And these components would be interactive, right? And so that's how you can kind of split the scalability needs of your application between static components and interactive components. And this basically makes your application more scalable because not the entire application doesn't need to be interactive. And so it sort of reserves that interactivity for only those users that actually need it. Number 2 item on this list was separating UI from business logic. So if we take a look at any of these components and we go down into the code area, first of all, we'll see that it's pulling in services, and then rather than doing actual direct data access with the database, it's actually interacting through services, right? All interaction happens through asynchronous service calls. And so this is the way that you would separate the UI from your sort of back-end business logic. And so by abstracting things into individual services is one way of doing that. The next thing is sort of building your APIs as independent services. So if we shift over now to the server side, the server project, we'll see that we have a set of services here, right? These are the actual services that the UI is going to rely on, but these services are implemented on the server. If I go to like the member service, right? We have, a whole set of different methods that the UI is going to be able to call. And these services then rely on a repository layer for doing the actual data access. but this nicely kind of layers your application and has the services separated into their own distinct layer that the UI can rely on. Using stateless approaches. So basically using stateless approaches to create scalable applications means don't use static variables, right? Don't use singletons. Use things that don't consume state. And then the other thing is also use infrastructure where the state can be centralized and shared. So in this particular application, obviously we have a repository. The repository is connected to a SQL Server database. So most of the state of this application is going to be stored in the database, right? It is never stored in the application itself. This application does use caching, and in that case, caching is another item on the scalability list, which I'll show you in a moment. But this is how you would build an application in a scalable manner, so that the state is not stored within the application itself, but it's stored separately in a database. Using dependency injection. So, right, as I mentioned previously, we had this component. We're injecting our dependencies. If we take a look at the actual declaration for when we do startup, we never register our services as singletons, right? We want these services to be scoped so that they are scoped to a particular user. And that also ensures that, that the state is never going to be shared across these services. They're going to be dedicated to each user. So minimizing data transfer is number 6 on the list. That was kind of recommended by AI. And so if we go into our repository, let's go into our post repository for a moment. We can take a look at some of the ways that it's actually trying to minimize data transfer. So one way, right, is by using things like take, right? So it's not returning the entire set of data in all cases, right? In this particular case, depending on the scenario, it's only going to return 6 items, right, by default in certain cases. In other cases, it's actually we're going to turn 1,000. And so you have to kind of be aware of the different use cases in your application, but that's one way to minimize sort of the amount of data. We're also using .efcore projections here, right, to create a model. And I think that the other thing to be aware of here is minimizing data transfer is not just about minimizing the amount of data that is transferred in each call. It's actually minimizing the number of database calls you make as well. And so in this case, you'll see that we're aggregating data. So I could very easily have created a separate service to get the total count of likes for a particular post, but that would mean it would be an additional service call that I have to make from my UI. Also, I could also have additional service calls to determine whether or not a particular member has liked this post. But instead of doing that, I've aggregated all of that information into a single model. So I'm doing one query on the back end and returning all of that to the UI. And so because of that, instead of making 3 different service calls to get the information I need for my UI, I can make one. So that's another of the ways that you can minimize data transfer, right? It's not just about making the data smaller, because I think when people think about minimizing data transfer, they often think, I got to use AutoMapper, I've got to use DTOs, I've got to create a lot of much smaller models. That's true. That can also improve scalability, but it's also about reducing the number of database calls that you make or service calls that you make. And in fact, what I've found in my career is that's where the bottleneck is usually. The more service calls you're making, the slower your application is going to be. And so if you can aggregate data into models that provide more of the result set in one service call, you're going to make your application a lot more scalable. Virtualization. So virtualization is a unique kind of feature in Blazor. And we'll go up to our messages area. And so I didn't show you this part of the application, but we'll look at this. So This application has the ability for members to send messages to one another. And so, of course, it has the ability for a member to view the messages that have been sent to them. We have this Virtualize component, which is a native Blazor component. And the purpose of this component is when you're rendering your UI, it is aware of whether or not certain items are visible on the page or not. And so it's only going to actually render items that are within the sort of viewport of your browser. And so that actually saves a lot of effort from rendering additional content that doesn't need to be rendered. And then as you scroll, it's going to automatically render the additional items as they scroll into view. We can actually see this in action. If I run this application again, I'm going to log out as this particular user and log in as one that perhaps has more messages. All right, so I'm logged in as sort of a host user, but we have this icon here which says I have messages. And so you'll see that it's a list of messages here. And these ones that are in the viewport have been rendered. And as I scroll down, you're not even going to really see any flicker or anything, but it's going to automatically be rendering those as I scroll. That's the whole purpose of the virtualization concept within Blazor. So it saves you from rendering a huge long list, right, of messages, and only renders those that are in the viewport. So quite a powerful feature that's part of Blazor, and that's obviously why the AI recommended that that's a great scalability benefit if you can take advantage of it. All right, using caching. All right, so if we go back to our repository for a moment, I am using caching here. So Oqtane has its own cache manager library, which is wrapped around FusionCache. FusionCache is a third-party library that is basically a hybrid cache. It handles both in-memory caching, so memory cache and distributed caching. And it also provides sort of cache synchronization if you're running in a scaled out environment. And so the list of nationalities in this application is static. There's no need to add or remove any of those nationalities. It's just a set of master data, so to speak. And so that data is cached, right? And we can use the caching library to sort of get the information from the cache. The first time the application runs, obviously, the cache item is not going to be populated, so it's going to load it from the database. And so that's how you can use caching very simply within your application to provide greater scalability. Making the database more efficient. So database access more efficient. So again, we can look at maybe our migrations for a moment. If I go in to look at my initialization code for the migrations that are run as part of creating this application, I can see that I create my models, right? I create my tables, but I also make sure I create indexes, right? So it's still important to do database tuning based on your individual database that you're using. Because indexes are going to provide a lot of scalability benefits to your application. I often see developers forget to go ahead and add indexes, right? They'll just create the initial table and forget all about the indexes, and of course then you're not creating a fully scalable application by doing that. And so it's important to always remember to create your indexes. The other thing that you can do is you can use things like in your repositories. Let's look at that post repository again. I don't think I have an example here, but you can use what is often recommended for EF Core is to use as no tracking, right? And that means that EF Core will not track. Because I'm using a projection here and using a select into a different model, I don't need to use as no tracking because as soon as you use a dot select, right, that means it's going to be a disconnected from EF Core. It's not going to be tracked at that point, so I don't need to use as no tracking. But that's another way that you can make your application more scalable. But of course, you need to pay attention to your use cases because you can't just throw as no tracking in all the time because there are some entities that you actually do want to track. Using background processing. So that would be for running longer tasks that should be run asynchronously. So in this application, I have a job, a rugby job, that runs in the background on a schedule. And what it does is it gets the members. If the member, hasn't verified their account, it sends out an email to them, like a notification saying you should, verify your account. If there's a new post that's created, it'll send a notification that there was a new post created to people who are, part of that team. So that's how you can run tasks in the background. This is using the I-hosted service, but Oqtane has a wrapper around that. And in fact, if we want to take a look at how that works, I can run the application. And I'm logged in as the administrator. So this is the functionality that Oqtane provides, right? It gives you a dashboard with a whole lot of built-in functionality that you can utilize as part of your application. I think for those of you who are not familiar with Oqtane, you'll think, oh, well, that's kind of like Aspire, right? Aspire has a dashboard where you can kind of view different aspects about your application. Oqtane has had a dashboard much longer than Aspire has ever had it. This was also a feature of .NETNuke when I created it. And so there's a lot of sort of fundamental features that are part of a web application that, why would you want to build those over and over again for every application? Things like user management, role management, file management. Like I was talking to Scott earlier about, broken URL management, managing multiple languages. Oqtane has a built-in search indexing engine as well. Scheduled jobs are what I wanted to show you. So it's got a list of the scheduled jobs that are part of the system. We have our rugby job, and we can set a schedule of when this job is supposed to run. This job is set to run every day at a particular, and this is the last time it ran. And of course, we can adjust the schedule, but you get all of this functionality by default when you're using Oqtane. The search engine, let's say I want to search for my daughter's name. It's indexed all of the content by default. That's part of this application. So, and I have links that can take me to various areas. I didn't have to build any of this. Search indexing is built in for all of the content. So a lot of great functionality that's included as part of Oqtane. So going back to the application, the other recommendation, number 11, was add observability. So if we go into our server application and we go into our program CS, we can see that I've added the OpenTelemetry configuration to this application. And this would allow me to use, an OpenTelemetry exporter, like, maybe I'm going to export to Prometheus. And then maybe I want to, use Grafana to, provide a nice dashboard of that telemetry data. I can completely do that by adding this kind of configuration to my application. It's very easy to do. And so this is also a recommended, practice from AI. And then horizontal scaling, right? Horizontal scaling allows you to scale out your application so you don't just have one instance. And if I run Oqtane again, I can show you how easy it is to do by using a framework like Oqtane. So if I go into the dashboard, I go into my system info area, it tells me a bunch of useful information about my existing instance that I'm running on. I can go into my options, go into caching. I can configure the different aspects of my cache, but I can also say that I want to use a distributed cache. If I say yes, I've got to provide a connection string for my Redis service that I'm using. If I'm using scale out, similarly, I need to provide the same kind of Redis service instance so that cache synchronization can happen across the different nodes that are part of my scale out infrastructure. So Oqtane provides you with very simple ways that you can configure things. Obviously, by changing these values, it'll update your app settings.json file. And then you can use your infrastructure. For example, if you're using Azure, to use it like an app service scale out capability to scale out your application. All right, and so with that, I think that we've gone through all of the different recommendations that were part of the building a scalable Blazor application story, at least the ones that were recommended by AI. The only one I guess I would say that I disagreed with was choosing the right hosting model. And I explained like the rationale behind how you should actually choose the right hosting model and not just choose Blazor WebAssembly, which is what AI came back with. And so thanks for joining. Like I mentioned, that I'm the founder of DevEssence, and we do a lot of consulting, creating applications using AI, using Blazor, using all of the tools that you're going to hear about today.